We're going to be solving a system of linear equations. A system just means there's more than one equation. It can be 2, 3, 4, whatever. They want us to solve them from graphing. So we're going to graph each one. We know their lines, so we can solve for y and get y equals mx plus b, graph the y-intercept and then the slope on each one, and find the solution. Now here's the key right here. Do you see this? There's exactly one solution when the lines intersect at a single point. If they're the exact same line, there's an infinite number of solutions. And if they're parallel lines, there's no solution. So you have to be careful that you're just graphing, each line separately. So they graphed it for us. And then we find the point where they intersect, and that would be our answer. So we have to graph each one, and then we can check for the answer. So what do they say here? They talk about how to graph each line. And then checking the answer. Oh, it's a really good idea to check it. You can go back to your original equation, plug in the point, and make sure it works. And if it works in both of them, you got your right answer. Well, you can be pretty much sure you got the right answer. Okay, so we are going to graph these. This one already has y equals, so let's graph that one first. We're going to do our y-intercept is -2. Our slope is 1/2, so we go up 1 and over 2. Remember, rise over run. The first equation, it would be nice if we could solve for y. So I have -x plus 2y equals 0. I'm going to add x to both sides. So I have 2y equals x. And then I'm going to divide by 2. So y equals x divided by 2. Did you know that when you have a number like x divided by 2, it's the same thing as saying 1/2 times x? So our slope is 1/2 and our y-intercept is 0. So we're going to put 0. Slope is 1/2, so we go up 1 and over 2. Wasn't our slope 1/2 in the other one? Okay, so they both have the same slope, different y-intercepts. They're parallel, which means they're never going to intersect, so there's no solution. Okay, this one we're going to go ahead and graph the first one because it's already in y equals mx plus b form. So we go to -1, put a point. Our slope is -1/2, so I'm going to go up 1 and to the left 2 to make it a negative slope. Then the second line, I'm going to use my pencil here, and we're going to solve for y. So -2x plus y equals 4. So we have to add 2x to both sides. So y equals 2x plus 4. These are not like terms, so we have to separate them with the plus sign. So our y-intercept is 4. We're going to go up to 4. Our slope is 2, which means 2 over 1. So we go up 2 and over 1. Then we look at that point where they intersect, and it looks like -2, 0. So we're going to put -2, 0. We'll start by graphing the one that's already a y equal. So we go up to 1, and our slope is -3. So we rise 3 and to the left 1 to make it negative. The first one, we're going to solve for y. I like to write the equation first. So we're going to add 6x. These are not like terms, so we have 6x minus 2, -2y. When I divide by -2, I have to make sure that I divide all of them by -2. So I have y equals -3x plus 1. Oh, check it out. It's the exact same line. Do you see that? So we'll graph it again just so they know we graphed it twice. I don't know if they're going to require that. But because they're the same line, they're going to be infinitely many solutions. Every point on that line is intersected with the other line. So it's infinitely many. And that's the end of the lesson.